Let us see now formation of PDE by eliminating arbitrary functions. So we have already discussed the formation of PDE by eliminating arbitrary constants, right? Constants, you know, we use letter A, B, C. Arbitrary constant, they can take any value, any value. It is arbitrary function. You know function which is f of x comma y, right? Arbitrary function, f of x can be of anything, x squared or x cube plus 4 or x cube plus x square plus x plus 9 or even sin x, right? F of x can be of anything which we call as arbitrary function. Similarly, f of x comma y, which is x cube plus y, x square plus xy square plus xy. So it is arbitrary. It can be of anything. Okay. Here we consider f of u comma v equal to 0, where f is the arbitrary function. Okay. F of u comma v is equal to 0, where u and v are functions of x, y, z. U and v are functions of x, y, z. You know, z is function of x, y, right? Z is function of x, y. Z is dependent variable. X and y are independent variables. So f is the arbitrary function here. Okay. So let us first eliminate one arbitrary function and we form the PDE. Okay. First we eliminate one arbitrary function and we form the PDE. You know elimination, right? Elimination. You remove and you have to get a PDE which is free from f. Okay. You have to get PDE which is free from f. So we have to eliminate this f. Okay. So first let us do elimination of one arbitrary function. Okay. And next we have elimination of two arbitrary function. Formation of PDE by eliminating two arbitrary functions. Okay. So let us consider first one arbitrary function f of u comma v equal to 0. Okay. Where u and v are functions of x, y, z. Okay. So the PDE can be formed very easily here if you use this method. The PDE can be formed if you use dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. The determinant, 2 cross 2 determinant, which is equal to 0. If you equate this to 0, you will get partial differential equation. Okay. And you know in arbitrary function we discussed, when there are only two arbitrary constants, when we have two arbitrary constants, we get first order PDE. When we eliminate two arbitrary constants, we get first order PDE. When we eliminate three arbitrary constants, we get second order PDE or higher order. Similarly here, if we eliminate one arbitrary function, we get first order PDE. If we eliminate two arbitrary functions, we get second order PDE. Okay. So here we get a PDE of first order, that is first order derivatives. That is P and Q. PDE which contains only P and Q. Okay. So this can help us to get partial differential equation if there is one arbitrary function. Okay. And if you expand this determinant, you have to get answer in the form PP plus QQ equal to R. You know this P denote dou Z by dou X. This Q denote dou Z by dou Y. This capital P, capital Q, capital R are functions of x, y, z. Okay. They are functions of x, y, z. We have already discussed in the last video, right? PP plus QQ equal to R is Lagrange linear equation. Lagrange linear equation. We are forming equation, right? So later in the next heading we solve equation. We solve equation, right? When we solve equation, we get solution. Now it is very clear we have two types of solution. One is solution with arbitrary constant, other one is solution with arbitrary function. Okay. So this, listen, when you solve this Lagrange equation, your solution will be in this form, f of u comma v equal to 0. So when f of u comma v is equal to 0, you will get an equation in the form pp plus qq equal to r. This is equation, this is solution. Here solution is given, we find equation. In the next heading, equation will be given, we find solution. Okay. So formation, we are forming equation here. Okay. So this equation will help us. This equation will help us to get answer. Okay. Let us do this problem. Form the PDE by eliminating arbitrary function from. Okay, it's very clear. F is the arbitrary function and this is u, this is v. Okay, where u and v are functions of x, y, z. Okay, so f of u comma v equals 0. We have to get answer which is free from f. This f is arbitrary function which is function of these two. Okay, so let us do now. So it is given u is equal to x minus y, v is equal to x plus y plus z. Dou u by dou x equal to 1. Differentiate with respect to x partially. Okay, with respect to y partially. Similarly, v with respect to x partially. It becomes 1, y becomes 0. Z is not constant, okay? Z is dependent variable. When you differentiate with respect to x, dou z by dou x. Similarly, dou v by dou y is 1 plus dou z by dou y. Okay? So now let us take, we know, PDE can be formed from dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. So which is C? Dou u by dou x 1 minus 1. It is 1 plus p, right? 1 plus p, 1 plus q. We know notation. Cross multiply 1 plus q minus of minus again, right? 1 plus q equal to 0. Which is 1 plus, right, 1 plus q minus of 1 plus p. 1 plus p plus 1 plus q equal to 0. P plus q equal to minus 2. So this equation is in the form pp plus qq equal to r, which is Lagrange linear equation. Whenever the solution is in the form f of u comma v equal to 0, our equation must be in the form pp plus qq equal to r, which is Lagrange linear equation. Okay, our answer must be in this form. Okay, answer is equation here, right? So usually in all the units it starts with the solve the equation, but here we have formed the equation, right? So when we solve the equation we get solution. When we form the equation, this is equation, right? This is partial differential equation because it contains derivatives. It is partial differential equation. The equation which contains partial derivatives called a partial differential equation. It is partial differential equation. So listen here, when solution is given, we find equation. Okay, let us see next problem. Form the PDE by eliminating phi from phi of x square plus y square plus z square comma x plus y plus z equal to 0. Form the PDE by eliminating. Okay, and phi is the function here. In the last problem f was the function, right? Here phi is the function. Okay, so it is phi of u comma v equal to 0. U is equal to x square plus y square plus z square. V is equal to x plus y plus z. So it is given phi of u comma v equal to 0. Okay, so it is C. First let us find dou u by dou x. 2x, y becomes 0, z become 2z, dou z by dou x. Dou u by dou y is equal to 2y plus 2z, dou z by dou y. When you differentiate with respect to x, y become constant. When you differentiate with respect to y, x become constant. Okay, because partial differentiation. Z is a dependent variable, it is not constant. Okay, so here similarly dou v by dou x is x becomes 1, y becomes 0. When you differentiate, z becomes dou z by dou x. Similarly dou v by dou y is 1 plus dou z by dou y. Okay, we know PDE can be formed with the help of this determinant dou u by dou y, dou v by dou x, dou v by dou y equal to 0. PDE can be formed from So when we eliminate one arbitrary function, this is the method, okay. So dou u by dou x is 2x plus 2zp. Dou u by dou y is 2y plus 2zq. Dou v by dou x is 1 plus p, it is 1 plus q. Because we know dou z by dou x is p and this is q, right? The notation. So this is which is equal to 0. Okay. We expand the determinant. 2x plus 2zp into 1 plus q minus 1 plus p into 2y plus 2zq equal to 0. Okay. So when you multiply first term into first term into second term into first term, second term into second term, minus of first term into first term into second term into first term, second term into second term. You remove this bracket, multiply this negative sign inside. 2x plus 2xq plus 2zp plus 2zpq minus 2y minus 2yzq minus 2yp minus 2zpq equal to 0. These two get cancelled. We know we should get answer in the standard form pp plus qq equal to r, right? So let us take small p common. It is 2z here. It is 2y here. 2z minus 2y. Okay. If you want, you can strike out 2 everywhere, right? You take 2 common, get that side, it will become 0. You can, let us simplify more. X plus x cube plus zp minus y yzq minus yp equal to 0. Take 2 common and divide by 2 both sides. Okay. Now let us take z, this p term. Take p common, z minus y into p, q common, x minus yz. See, it is wrong. Where is the mistake? Let us see. yzq. Here. First term into second term, 2zq. It is not yzq, 2yzq, simply zq. So it is x minus z into q. Then pp plus qq equal to r. What is r here? Get x this side and y this side. Y minus x. So which is the required partial differential equation. Okay. See, which is in the form pp plus qq equal to r. Capital P small p, capital Q small q equal to r. Right. So whenever the solution is in the form phi of u comma v equals 0 or f of u comma v equals 0 or g of u comma v equal to 0, whatever it is, if it is in the form, then our solution our equation must be in the form pp plus qq equal to r, which is, this is partial differential equation because it contains partial derivatives p and q. And you know, if you eliminate, this answer is free from phi, right? This answer is free from the arbitrary function phi. So this is a partial differential equation, right? First order partial differential equation. If you eliminate one arbitrary function, our answer will be first order partial differential equation. Okay. So we shall see another problem. Form the PDE by eliminating the arbitrary function f from z equal to f of y by x. So the arbitrary function is f. So usually we will have a function in the form f of u comma v equal to 0, right? Arbitrary function in the form f of u comma v equal to 0. But here it is different, right? And you should know this f of u comma v equal to 0 can be written as u is equal to some function of v or v is equal to some function of u. Okay. The same f of u comma v can be written as u is equal to function of v or v is equal to function of u. So it is u is equal to some function of v given. Okay. So if you want, you can rewrite it as the given equation can be written as phi of z comma y by x equal to 0. See, when u is equal to phi of v or f of v, then that can be written as, if it is phi, it is f here because It is function of v. So we should use different notation. We should use different letter phi. It is f. Function of u and v, f. Function of v, phi. Right? So similarly here, function of y by x is f. When I write, I should change f into phi. Right? F or some other letter. Some other letter. Okay? Your choice. The given equation can be written as phi of z comma y by x equal to 0. So you should know one thing clearly. When f of u comma v equal to 0, it can be written as u is equal to phi of v or v is equal to g of u, some function of u. Okay. So whatever it is, let us rewrite it as phi of u comma v equal to 0. So it's very clear, u is equal to z, v is equal to y by x. Then the same method. Differentiate u with respect to x. Z is not constant, okay? Dou z by dou x. Differentiate u with respect to y. Dou z by dou y. Dou v by dou x. It is u by v. If you want, you can use, or you can directly differentiate. Keep x, differentiate y 0. Keep y, differentiate x 1. Minus y by x square. Dou v by dou y. U by v again. Keep x, differentiate y. Dou y by dou y, which is 1. Right? Minus keep y, differentiate x 0 divided by x square, which we have x by x square, which is 1 by x. 1 by x, okay? So we know the PDE can be formed from dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. Since dou z by dou x is p, the notation, right? Similarly, it is q. It is minus y by x square. It is 1 by x. Now expand the determinant. It is p by x, minus of minus plus, qy by x square equal to 0. Take x LCM, x square LCM. It is px plus qy equal to 0. When you take x square LCM, see, px plus qy by x square equal to 0 or px plus qy equal to 0. So answer is px plus qy equal to 0, which is the required PDE. This equation is in the form pp plus qq equal to r. pp plus qq equal to r, where capital P is x, capital Q is y, capital R is 0. Okay? 0. P, Q, R are functions of x, y, z, right? And don't think R is 0. R is, if you want, you can write R is 0x plus 0y, which is function of x, y, right? So it is, our answer must be in Lagrange form whenever the solution is in the form is f of u comma v equal to 0. See how I am saying? The solution is in the form because this is equation. So we will see later in the next heading, we solve this type of equation and we will write answer in this form. In this form, f of u comma v equal to 0. Okay. So we shall see another problem. Form the PDE by eliminating f from z equal to this one. Okay. So usually question will be f of u comma v equal to 0 or u is equal to some function of v or v is equal to some function of u. But this question is neither in the form f of u comma v equal to 0 or nor in this form. Right? This question is. So we have to rewrite it as, rewrite in the form. Let us bring y square this side. Bring y square this side. Then bring 2 also this side. Now which is in the form u is equal to some function of v. Right? So usually question must be in the form when you eliminate one arbitrary function. Question must be in the form f of u comma v equal to 0 or u is equal to some function of v. Or v is equal to some function. You need not consider u is equal to function of v. So bring this, let us rewrite it, okay. Since it is not in the standard form, let us rewrite it. Now it becomes u is equal to some function of v. Okay, f of f is given here. U is equal to f of v, okay. So where u is equal to z minus y square by 2, v is equal to 1 by x plus log y, okay. Differentiate u with respect to x. Take 1 by 2 outside. Differentiate z with respect to x. Differentiate y with respect to x, 0. Similarly, listen here, take 1 by 2 outside. Differentiate u with respect to y. Z is not constant, okay? Dou z by dou y minus 2y, okay? Similarly, dou v by dou x, which is, when you differentiate with respect to x, 1 by x becomes minus 1 by x square, right? Otherwise, use u by v method. Or take x to numerator, which becomes x power minus 1. Differentiate x power minus 1 x power minus 2 or minus 1 by x square. Log y becomes 0 when we differentiate with respect to x. Differentiate v with respect to y. This 1 by x becomes 0. When you differentiate log y, it is 1 by y. You know PDE can be formed from dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0, right? So this 2 cross 2 determinant will help us to get answer. What is dou u by dou x? See, it is dou z by dou x is p by 2. It is q minus 2y by 2, right? P by 2, q minus 2y by 2, right? Q minus 2y, right? Minus 1 by x square, 1 by y. Minus 1 by x square, 1 by y equal to 0. You cross multiply p by 2y, minus into minus plus q minus 2y by x square. Let us take LCM. It is 2y x square LCM. Px square 2y into q minus 2y equal to 0. Cross multiply px square, multiply this 2yq minus into plus minus 4y square equal to 0. Or this is x square p plus 2yq equal to 4y square, which is the required partial differential equation, which is in the form pp plus qq equal to r, where capital P is x square, capital Q is 2y, capital R is 4y square. P, Q, R are functions of x and y. If you think R is function of y, you can write 0x plus 4y square, which will become function of xy, okay? So this is Lagrange linear equation. So our answer here, when you eliminate, our answer is free from arbitrary function f. So we have eliminated f, right? We have eliminated f from the problem. And we have formed PDE. So we have formed PDE by eliminating arbitrary function, okay? And we have got answer in the form Lagrange linear equation, okay? We shall see one more problem. Form the PDE by eliminating arbitrary function from this one, right? So the given question is in the form u is equal to f of v. Whether the question is in the form f of u comma v equal to 0 or u is equal to f of v, we know method how to do, right? How can we find the equation? Right? So let us take u is this lx plus my plus nz. V is this x square plus y square plus z square. Differentiate it with respect to x, which is L, where element are constants. My becomes 0 when we differentiate with respect to x. And we know very clearly z is dependent variable, not constant. Dou u by dou y. Lx becomes 0, my, m take m outside, y becomes 1, n into dou z by dou y. Similarly, dou v by dou x, it is 2x plus 2z into dou z by dou x. I hope you know differentiation. So I am going fast. 2y plus 2z into dou z by dou y. Okay. We know PDE is formed from, PDE equation is formed from 2 cross 2 determinant, dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y equal to 0. Okay. Dou u by dou x is L plus NP. We know notation. L plus NP. This is M plus NQ. This is 2x plus 2ZP. This is 2y plus 2ZQ equal to 0. Expand the determinant. 2y plus 2ZQ into L plus NP minus of M plus NQ into 2x plus 2ZP equal to 0. Let us multiply first term into first term into second term into first term, second term into second term, minus of. Similarly, okay. So which becomes 2Ly minus, I do it, okay. I have here 2Ly first term into first term into second term, 2NYP plus 2LZQ plus 2NZQP. See, listen here. I have multiplied. It is 2Ly, 2NP, right? 2YNP or 2NYP. Similarly, 2, it is L, okay? 2LZQ. It is 2NZPQ. Minus of, similarly, M into 2X, M into 2ZP. Let us do, this is a parenthesis here. Minus of M into 2X, 2MX, M into 2ZP, 2MZP. Similarly, 2XNQ. Similarly, 2NZPQ equal to 0. Okay. I have multiplied the terms. That's all. Let us remove this parenthesis by multiplying negative sign. 2Ly, 2NYP, 2LZQ, 2NZPQ minus 2MX, 2MZP. It is minus 2NXQ minus 2NZPQ. It's very clear these two get cancelled. And this becomes, see what it becomes? We know the form is PP plus QQ equal to R. Let us take P term. This is P term, this is P term. Take small p common. What we have? 2, very good. Listen here. Yeah, we have in all the terms 2, right? Take 2 common. It becomes Ly plus NYP, LZQ minus MX minus MZP minus NXQ equal to 0. Divide throughout by 2. Ly plus NYP plus LZQ minus MX minus MZP. We have to do this simplification because our answer must be in standard form. It is P term. Take P common. NY minus MZ into P. Take from these two terms Q common. LZ minus NX into Q equal to R. Let us bring other terms this side. Minus MX become plus MX, plus LY becomes minus LY. Which is the required partial differential equation. See, this is in the form PP plus QQ equal to R, where P, Q, R are functions of X, Y, Z. Okay. I hope you have understood this heading. Elimination of one arbitrary function and forming PDE. We shall see in the next video eliminating two arbitrary functions and getting PDE. Okay. Thank you.